Now about this subject, we'll go through the formalities of it, the description of the subject and some of the formal parts of it all. Okay, so the description: this subject teaches students current industry practices to design, develop, and evaluate software architecture meeting predefined quality characteristics of functionality, suitability and security, usability, including operability, efficiency, that is time, behavior, and resource utilization, and maintainability, that is it easy to change, is it easy to test. The concepts and theories and technologies underlying the methods and techniques are introduced and explained as required. Students apply the industry practices they have learned to develop an architecture of a business system, more or less. All right. Now, the whole field of software architecture is huge. There are people who spent, say, 30 years learning about software architecture, and they're really slick. I can't teach you what they know in one term of teaching. So we pull in the subjects that are needed as they're needed, and you pull in more information as you need it. The learning objectives: every subject we teach has to have some objectives, and these line up to fill various objectives in the degrees and so on and so forth. So the objectives for this particular subject is to be able to describe the factors that affect the architecture context and requirements, including stakeholders and their interests, architectural qualities, business requirements, and usage scenarios. So you should be able to do that. Develop and refine multiple views of software system architecture based on the conceptual, execution, and implementation architecture. These are the three basic views of a software architecture. There are arguments there should be four. I haven't actually found much use for four. I found much more use for three. And there was a seminal paper written by Philippe Kruchten about the 4+1 view of software architecture. And the +1 is the collection of scenarios that unite all the different architectures. Third objective is to understand the key issues in choosing and implementing architectural patterns, including performance, testing, security, usability, maintainability, and reliability qualities. Okay? I'll deal with that later, but basically the whole idea of architecture patterns has probably been superseded by frameworks. So we'll go into that at the time. The fourth objective is to be able to reason about alternative architectural designs to satisfy system quality attributes. Now this is important because it's not enough just to go and get one answer, any answer. You really should be able to come out with different architectures that are better suited to different circumstances. This is because there isn't any one answer. A lot of answers will work, and a lot of the qualities of software architectures do contradict each other, and so you can favor one as opposed to the other, and as a consequence you get different architectural answers to the same problem. The last objective is to develop a complete software architecture for a proposed solution to a realistic industry problem. And that basically is your major project, and it's the test piece of do you know the subject. Now, the teaching and learning strategy. This is, how would you call it? Flipped learning. This is facilitated self-learning. The old style of some expert standing in front of the room and prattling on is gone. You can get your information about software architecture from anywhere. And I'm only one source of it, and possibly not even the best source of it. There are some really good sources available through the internet. So forget about the whole idea of coming to university to find out about software architecture. What you come here to do is to apply it and learn what it means in the context, and to practice, and to collaborate with people to augment your learning. That's what you come to university for. That's what you come to campus for. So it's taught through facilitated self-learning. All lectures and related material are available online. That is, they're up on YouTube. They may be viewed at the student's convenience, which I think is great. It means you can view it whenever you feel like it. And if you happen to feel like it at 2 in the morning, well, that's for you to decide. I'm certainly not going to be teaching it to you at 2 in the morning. Quizzes are provided to enable you to check your understanding. Now, the quizzes are there. They're set up in particular ways. You get multiple chances at them, and generally I take the best mark. Students are expected to have studied the tutorial topics in preparation for tutorials. You must turn up to tutorials knowing what you're talking about. You must know the topic by the time you come to tutorial. Tutorial is not a place to learn about the topic. It's a place to practice, to try, to see how it works. Now, during the first half of the term, the tutorials will demonstrate the topic through application to a problem. Any problem, just a problem. All right? Followed by a student evaluation. The students will perform an exercise and evaluate each other's work in order to develop their skills in collegial review or critiquing and ability to identify where an architecture might fail. Now, this is a fairly major part of how this topic is taught and how you learn. I've been using peer reviews for a number of years, and they work better than anything else I've come across. So they're here to stay. Now, during the second half of the term, students will be working on a major assignment. During tutorials, each team will present to another team the architecture phase or output that's appropriate on that day. Right? And teams will critique each other. Now, the reviewing team will evaluate the presented architecture and provide feedback to acknowledge what's good, what's not good, and what can be improved. Now, the review feedback will be communicated to the presenting team as soon as possible after the presentation. I say as soon as possible. It's usually before about 11 o'clock the next morning. This is because, having had a certain amount of practice, it takes me about an hour and a half to format all the information and feed it all back. Now, what is important, and we'll deal with this in peer reviews later, is that if you don't submit a review, you don't get any marks. All right. Now, some administration topics that I have to deal with because you have to have been warned. Right? Plagiarism. Don't do it. Plagiarism is misconduct. Now, personally, aside from the ethics of it, I don't have any particular concern about plagiarism, because when you get out in the industry and you just simply copy something, well, good for you. However, this is a university where I have to be assured that you understand what you're saying. And if you have simply copied someone else's work, I don't know whether you've understood it or not. I know you copied it, but I don't know whether you've understood. So I can't give you any marks for it. So that's my problem with it, is that if you plagiarize, I can't give you marks. Right? It happens that the university is pretty hot on plagiarism, and we have ways of detecting it through Turnitin. And as soon as it is detected, I get no choice. I must report it as misconduct. I don't have the discretion anymore. So don't plagiarize. Now, more importantly, if you're in a team and various team members contribute to the overall assignment, the group is responsible for the submitted work. If part of it is plagiarized, it doesn't matter. The whole group catches it. So don't plagiarize, and check that no one else in your group has plagiarized. Now, another administrative topic that I come up against increasingly is appeals against marks. Now, to be fair, we don't always get it right. I provide a marking scheme and I try to explain it as best I can. It's obviously very clear to me. It may not be quite so clear to you, so you might interpret it differently, and you might answer to a different, provide a different answer, and you get your marks back and think, no, hang on a bit, that's not right. Okay, that's fair enough. You can appeal. However, you have to do more than simply hold your hand up and say, I appealed. You actually have to document what was marked incorrectly and why you believe it was marked incorrectly. and incorrect against the marking scheme. Not incorrect because you don't like it. It has to be assessed against the marking scheme. So if you believe that the assessor, and that could have been me, looked at the marking scheme and assessed the work wrong because they overlooked something or misinterpreted something, then you say that, and you must document exactly what was badly assessed. Then you must also say what you think the correct mark should be according to the marking scheme and why you think that is the correct mark. All right? So that's what you've got to do for an appeal. I'm not interested in appeals that just say, oh, that was too hard, or they marked us hard, or it was wrong, or I don't like it. Not good enough. You have to go through the whole mechanics of saying what was wrong and why it was wrong, what should be right and why it should be right.